Today I'm pleased to introduce the invited presidential symposium featuring Drs. Paul Sackett and Nathan Kuncel. They're renowned scholars in industrial and organizational psychology and are distinguished professors at the University of Minnesota. The research funded by the College Board is the basis of today's talk. Welcome, gentlemen.
Thank you, Mike. Good morning. I think we're probably going to give the poor people with the camera a hard time. Neither of us like standing behind the podium. Thank you so much for giving us the chance to come talk to you about this work that we do. As Mike says, our background is industrial organizational psychology. Our work looks broadly at the prediction of performance in a variety of organizational settings, and we include academic institutions as organizations, and we have this large-scale program of work on admissions testing. Seeing the international nature of the audience here, I need to back up and give the 30-second overview of what we mean by admissions testing, which is a big deal in the United States and less so, or not an issue at all, elsewhere. But in the United States, long history of standardized tests for undergraduate admission, two major tests. You hear those names thrown around today, the SAT and the ACT. They generally are used in different regions of the country. And similar, there'll be tests for graduate admission, law school admission, medical school admission, etc. Now these, generally the issue is students take these, the information is made available to the schools. Schools are free to do with them what they want. They can ignore them, they can give them modest weight, they can give them a very high weight. So that's the overview of sort of our admissions system. Anyway, this is the kind of thing that drives us nuts. Here's a quote, and I'm not going to attribute it out of kindness. Whether the GRE, graduate record exam, predicts performance is currently under dispute. Kuncel says it does, Sternberg and Williams say it doesn't. Well, Sternberg and Williams is one sample of 169. Kuncel is 1,753 samples. So in what we're doing here, in this whole area, you can certainly find small sample studies that will produce any finding you want. If you're out searching to make a political point, you can go find it. Our goal in what we're doing here is to say, let's get the best data we can, and let's see what we can do to really nail some of these things down. Most of what we talk about today, it'll go a bit beyond it, most focuses on two, I use here the word very large data sets. This comes from the College Board. The College Board initiated the data collection. Whenever they revised the test, they'd start a data collection effort because, of course, it's their professional obligation to document validity of a revised version. So there was a revision in the mid-90s. So a set of studies, data was collected in the mid-90s, 41 schools, 150,000 students. Then a revision in 2005, leading to a big data collection that started then, has continued to the present, over 250 schools, over 1.2 million students. So that's the data we work with. I'm trying to define a word. As I was in the conference yesterday, I heard in one talk the word 5,000 described as massive. Another talk used 12,000 as massive. So I guess with our 1.2, the grad students use the word ginormous, so I'm going to use that. So this is our ginormous data set. So lots of students entering cohorts followed throughout college. We've got all kinds of data here. Wish we had more, but we've got a lot. So test scores, the SAT test, various advanced placement tests, that's not what we're going to talk about today. Their performance in high school, grades, course taking, AP courses, honors. A lengthy questionnaire that students complete when they register for the test, and that proves to be a rich data source that we can do a lot of interesting things with. Activities they've participated in, self-assessment of ability, SES, aspirations, plans, so several hundred pieces of information. So basically we've got hundreds of variables on well over 1 million students, and that's a lot of stuff. At the bottom is something that's really critical here. We have complete data on each course taken in college. So normally in this kind of work you get a GPA as a criterion. We will have their grade in English 1, their grade in cultural anthropology, etc. And there's all kinds of wonderful things you can do when you've got data that specific. And so you'll hear today about ways we exploit having that kind of data in our work. So we're going to start basic and move on from there. The interest, I think, about all of this is that there's lots of topics that are debated among groups of fine scholars like we have here. We get together once a year and we try to push the field further forward. In the admissions testing area, it all takes place in public. It all takes place on the front page of the New York Times, in the New Yorker, in the Wall Street Journal, etc. So this is all very interesting. But common claims. The SAT predicts nothing of value. So here's a couple recent. Leon Botstein in Time. Only persistent statistical result is the correlation between income and test scores. And as it befits an exam named for itself, the SAT used to stand for something. Now it just stands for the SAT. It measures those skills and only those skills necessary to get a high score on the test. So you get these claims that it does nothing. So let's answer so what does it predict? Well, here's the large sample answer for step one, and we're going to push it from here. The observed correlation with first-year grade point is consistently 35 plus or minus correlation point from sample to sample. Now, here's one way to frame it. Here's mean freshman grade by score band, so just dividing it into 5 equal score intervals. And I look at that and say, yeah, it certainly matters. If I'm a school, it's the strategy one says, I bring in people in a band that gives you a 3.53, that's half A's, half B's, as opposed to one that brings you in a 2.62, half B's, half C's. It's hard to imagine anybody saying, I'm indifferent to that as the kind of student body I'm going to get. If you'd like to do it differently, this is percentage of students getting a grade point average of B or higher by that score band. And again, odds, it's all probabilistic. And of course, you can criticize and say, I know one who, somebody with a low score and did well, etc. But you look at those odds and say, it looks to us pretty compelling that there's a really strong case for this being a useful piece of information. But that's observed correlation. Now, what do we see if we correct for restriction of range, which is terribly important? You're studying observed students, but the question is how well does it do in predicting with the applicant pool? So we see our 35 that we just saw. Second, in college-specific applicant pools, okay, we've got data on over 200 schools, so everything we're doing is computed within school and then viewed as hundreds of replications. Correct for range restriction to the applicant pool for that specific school, and your 35 goes to 47. If you correct to the national college-bound population, you get a 54. So range restriction is a big deal. So in the population we're interested in, which is the applicant population, not the selected, you predict quite a bit better. But we're not done yet. Noise in the outcome measures affects validity. This is something we all know, but we don't think about too much. We all sort of acknowledge, yeah, grade point average. Students differ. They choose differing patterns of hard and easy courses. Sometimes it's intentional. There's the student who goes out of his way, her way, to find the easiest possible courses. What's the reputation of this professor? And then there's the student who naively stumbles into an indescribably difficult curriculum. So we know that happens, but we, up to this point, have had no idea of the extent to which that affected our results. So the real question is, what would happen if students took a common curriculum? And generally, that's not an experiment a college is willing to do, so we don't have good answers to it. But we can exploit our data set in what I think is a useful way to answer it. We can examine validity separately within each individual course. So if I'm looking at how well does the SAT predict the grade you get in world history at Amherst College in the spring semester of 2008, I get a validity coefficient for that. And I keep going and I compute over 150,000 separate validity coefficients. So I'm doing the world's largest meta-analysis. Those who know my colleague Denise Owens, in the next office to mine, she takes pride in large sample stuff, and I never cease to tweak her about saying, tell me when you get 150,000 effect sizes in your meta-analysis. So 150,000 course-specific validity estimates. Now, though that removes all this, it's the same instructor, same setting, and then you get the mean of that. That's how well SAT predicts performance in the average course. Spearman round that up to the 10.33 courses taken on average in the freshman year, and you get an estimate of what validity would be if students took the same curriculum. You following the logic? And the answer is 67. So the effect of that noise due to student choice is large, and I think larger than a lot of people would have expected. We can apply this logic to the SAT high school combination. You can do this whole thing with high school grade as well, and clearly the same things apply. High school grade is highly valid. Those are the two major pieces of information. Each has quite meaningful, as you see here, incremental validity over the other. But once you've gone through this exercise, take care of range restriction and control for the idiosyncrasies in course taking patterns. And these two common predictors do really a very good job. Anybody who's saying the stuff you guys are using to select students maybe have some tiny value at the margin, but surely the really important stuff you haven't got to yet. That's the message we get all the time. And our message is a very, very different one. There clearly is room to find increments at the margin here, but we're covering most of what matters. Does that make sense? So what we've just said in graphic form, starting SAT observed, higher value applicant population for a school, the college-bound population, SAT with a common curriculum, SAT, high school grade combined. Here's our estimate of how well we predict. Now, an additional tweak to this, the critics' assertion, well, above a threshold, higher scores don't matter. And that's popularized by Malcolm Gladwell, and you see it in a variety of other places. You know, once you hit the needed threshold, it'll level off. And, well, here's what we see in our data, and it doesn't. This version is fitting a line. I've got another version of it where we got enough data that I plot the point. Here's the mean GPA for students with a 610, and here's for students with a 620, and just literally connect the dots, and you get this. It's so clear and so powerful. It clearly doesn't level off. If anything, it looks like there's a slight upward slope. But here's a bunch of other data sets looking at the same thing, large scale. Project A is military, so that's predicting military performance. The other three are academic performance. The College Board I already showed you, the NELS, the National Educational Longitudinal Study of 1988, and the classic old Project Talent. So three that are predicting college grades and one predicting performance in the military. In none of these settings, with none of these very large data sets, do you see this leveling off. You know, once you're at this threshold, it's good enough. And if anything, there's some pretty good evidence that our slope is increasing, not decreasing. So it's exactly the opposite of what the critics would say. So that's the initial story on validity. And at this point, we switch to Nathan.
Thank you for having me. So in this section, we're going to talk a little bit about other things that tests predict. Do measures of intelligence predict a variety of different important life outcomes? We could rename this section Preaching to the Choir. So I'll try to keep actually this sermon short because I think there's quite a bit of knowledge in this room about the importance of cognitive ability measures. But typically, if you look at discussions of things like admissions testing, you'll hear things like, oh, tests only really predict first-year grades, and they don't even really predict it that well. But in this study we published in Science based on over 3,000 samples and 600,000 students, we see that everywhere we look, actually, admissions tests across fields ranging from physics to medicine to law school, business, and pharmacy, they predict a wide range of different outcomes, including things like producing research and being evaluated as highly competent by faculty and developing expertise. And even predicting whether people finish the degree, although to a lesser degree, except for the subject test, which is something that we'll get back to later. So this is fiction, and this is fact. So what about job performance? Well, at this point, IO Psychology has accumulated a lot of studies. And we did a review where we talked about data from 21,000 plus studies with over 5 million people. I put the sample size in scientific notation because I can. And what we find consistently is cognitive ability predicts job performance. And if you break it down, you get some interesting patterns, like you get stronger relationships for higher complexity jobs. You get very robust relationships with training success, how quickly people acquire job-specific skills, both in work and both in military and civilian jobs. But even interesting stuff like relationships with creative performance in school and work settings, as well as objective leadership success. Leaders who have higher cognitive ability scores, their teams, their groups perform better. And another thing that we've looked at quite a bit with the data that we have, I think is very important. We're looking at the question, is really a degree a degree a degree? In other words, you can get a bachelor's degree in psychology, but I think we all know that a bachelor's degree in psychology is not necessarily the same across students. At Minnesota, you have the opportunity to essentially leave almost with a master's degree level education, or very much less than that. And so we got interested in looking at things like, do SAT scores relate to taking a large number of advanced level courses? And they do. They're correlated with it. Those students who have higher scores are much more likely to take difficult, challenging courses. They take more difficult courses. In other words, even within the same course, they'll tend to take one that is more rigorous and more challenging. And they tend to do less major switching to less challenging majors. Students with higher test scores tend to stay in challenging fields and tend to be less likely to say, well, the classic example is, wow, organic chemistry is really hard. I guess I'm not going to be pre-med anymore. You get much less of that with higher test scores.
Yes, it's my turn again. That was quick. I didn't even have enough time for my soft drink. Anyway, social class effects. Again, want to address an issue that is all over the place, lots of concern. The assertion is predictive power of tests is simply a function of socioeconomic status. Okay, and here's a handful of quotes. You know, in the interest of truth in advertising, SAT should be simply called a wealth test, merely measures the size of students' houses, only thing it predicts is socioeconomic status. Parsing the results by income suggests that it should be called the student affluence test. So you get these kinds of claims. Graphs like this have appeared in major media outlets all over the place. We picked Washington Post, but the same graph appears in the Wall Street Journal, in Time, all over the place. It's more complicated than it needs, but the message that's delivered, it's the three subtests of the SAT, but the total across the top. Oh, look, as income increases, we see increasing SAT scores. So there's no question that there is a relationship between SAT scores and family income. But somebody got it right, the reporter at the Wall Street Journal. A final caveat, after showing a graph like this, said, within each income category, of course, there's a tremendous amount of variation. Having wealthy parents gives a leg up, but parental income is not destiny. Pleased to see that kind of statement. And so this notion of, is that, well, here's what that looks like for real. In pink is, well, whatever, rose shows up here, is the lowest income. These are students with parental income under $20,000. So that is really, really low income. And then at the other is income over 100,000, and just the overlap in distributions. Mean difference, absolutely. Lots of variation within each group, enormous amounts of overlap. But that's descriptive. Now we need to ask the question, what role does SES play in accounting for or explaining away the predictive validity? Frankly, this whole program that we're talking to you about today emerged from reading the American Psychologist around 2003. 2 articles appeared that same year. Crosby et al. It's now been documented with massive, here's the word massive again. Their massive meant 78,000. Okay, massive data sets from the University of California that SAT loses any ability to predict grades if the regression analyses control for socioeconomic status. I mean, I read that and said, oh my goodness. I mean, I'm a testing guy. I want to know what's going on. Okay, what's a mental note, follow up on this. And then a couple issues later, here's another paper, American Psychologist, SAT, doesn't predict when SES is controlled, and we got to follow up. As a guy who needs to know how it works, we got to get into this, and that's what got Nathan and I into all of this stuff. So within our data, what's the story? We're sticking with our observed correlations. The pattern's going to be the same if we do our range restriction corrections, but for simplicity, here it is. That 35 correlation we've seen before between SAT and grades. SAT and SES do correlate, 22. SES and grade, 06. Controlling, partial out SES, and your 35 drops to 33. Does it drop to 0? No. 35 to 33 is trivial. So we presented that, published that in Psych Bulletin and a follow-up in Psych Science, and people say, I still don't believe it. Now, there's several reasons why they don't believe it. One is, no matter what you do, they won't believe it. The other is, I don't quite understand. You psychologists and psychometricians, this concept of statistical control, which is second nature to us, is not second nature to the general public. So we've got a brand new paper where substantively it's nothing new, but in terms of presenting the findings, we say, okay, instead of doing statistical control, our data set is massive. So we're going to compute validity separately within every $10,000 parental income band, okay? So this notion that if it goes to zero, holding it constant, well, here's one way to look at it. Let's look at people whose parents all make the same amount of money. Does it still predict? And here's our answer. Just sort of random seeming variation, up a point, down a point, between 30 and 35 within each of our income groups. So I think that really, we thought, okay, that should set it all to rest. Critics came back with a revised claim. What you're doing there looks just at the SAT. You need to look at SAT in conjunction with high school grades. When you're looking at both of them, the SAT regression will go to the regression coefficient will go to zero with both SES and high school grade in the model. So with our data, what happens? Model 1, SAT and high school grade, there's the regression coefficients for both. And model 2 adds SES. Does it go to zero? No. So how did this, in California data it goes to zero, and our data it doesn't? What's going on? Well, we need to take a look at the California data. So there's the California data. Looks like our data to me. You know, so how on earth does Richard Atkinson make a claim that the validity is, quote, decisively diminished, a wonderful turn of a phrase, when you control for SES? We find, you know, with comparable models, we get comparable findings. Look more closely at what the California folks actually did. This is Geiser and Studley, 2002. They tested a different model. When they added SES to their model, they also added another variable, added a second test, the SAT-2. Now, the SAT-2 is a test used in some places, used in California, an alternative that it involves taking a math test, a verbal test, and a third test of the student's own choice. So you could take, one student can choose Spanish, another can choose history. An interesting model, and frankly, this SA1 and SAT2 correlate about as highly as one form correlates with another form of the other. So basically, what happens when you put in a clone of the same test? So this is what's going on. It's adding the SAT2, not SES, that drives the reduction in coefficients. The first two rows you've seen before, right? When you add SES, it does nothing to the SAT coefficient. When you add SAT2, then our coefficient for SES does go to zero. So the claims and the American psychologist story is based on this 0.02 right here. And that's interpreted as when you add SES to the model, SAT goes to zero. No, when you add another test that's effectively a clone of the test, all the weight goes to one of the two, and in the model, all the weight goes to the SAT2. You with me? Okay. So our conclusion, with comparable models, the California data and our College Board data produce comparable findings. SES neither accounts for the bivariate relationship with performance, nor substantially diminishes SAT's weight when SAT and grades are used to predict academic performance. A couple of additional observations before I give it back to Nathan. The precise cause of the correlation between SES and test scores is not addressed in our research. We're just being descriptive here. But in possibility one, high SES individuals have got the money to buy coaching, which artificially inflates test scores. So that's a line one hears. Something that I find very, very useful here is Rebecca Zwick, some wonderful work, where she examines SES test correlations for high-stakes tests like the SAT, and low-stakes test, the spelling test that your teacher gave you last Thursday. And finds similar SES correlations for high and low stakes tests, which argues against the argument that it's nothing but buying coaching for the high stakes test. I think that's a really insightful observation. The other possibility is high SES individuals really just plain have access to a better learning environment and do learn more, and there's tons of evidence in support of that, and there's not time to review that today. So our sense is the relationship is there, it's real, as a social problem, but it's not, it's not a statistical artifact, okay? And one last point, comparable findings, controlling SES doesn't reduce validity in employment settings. So the same pattern in employment that we see in the higher ed setting. And that takes it to our next topic and back to Nathan.
All right. So Paul and I have been also interested, though, in what other characteristics predict success in academic settings. And we've had both information from these large data sets to examine that question, but have also pursued other avenues of research as well. And one of the things that we got interested in is this idea of critical thinking. We were both involved in a National Research Council board that was talking about 21st century workforce skills, and critical thinking came up over and over and over again. And I wound up working on a report for that group, trying to talk about what exactly is critical thinking and how is it measured and does it matter. And we've done a series of studies looking at this over the years, and I think it's very interesting because critical thinking is often proposed as a hugely important thing that everybody needs, but no one really defines very well. And so I'd like to try to correct that here in a few minutes. So you get a lot of different definitions about critical thinking, including things like critical thinking refers to the use of cognitive skills or strategies that increase the probability of a desirable outcome. I think Halpern's work, I sign a lot of it in my class, is great. I think she does excellent research. But with this definition, I'm not sure what it does not include. I think it's pretty much all good human behavior that involves cognition is critical thinking. And I don't think that's a particularly useful definition. Critical thinking, the ability and willingness to test the validity of propositions is, I think, better, but even that seems overly general. Is it the same entity, critical thinking, for physics as it is for psychology? I would seriously doubt it. Often when you hear discussions of critical thinking, you hear things like these, what I would call specific skills, sunk cost, decision bias, sample bias, use of control groups, affirming the consequent, and so on. And often these things are rolled into tests of critical thinking. As I was doing the review, I read as many papers as I could, and I started collecting coefficients and doing a meta-analysis along the way because I have a problem. I automatically do that. I can't help myself. So these are the results from the meta-analysis that I did as I was supposedly doing a narrative review of the field. And we get critical thinking correlating with critical thinking in the low 40s, and critical thinking correlating with general cognitive ability slightly better than that. The general cognitive ability measures are typically a little bit more reliable, so we'd expect that. And this immediately kind of raises the question, is critical thinking really any different than the stuff we've already got? Are critical thinking measures nothing more or less than ability measures that we already have? We see correlations with an absence of superstitions, both for cognitive ability and critical thinking, that aren't particularly large, but would be in the direction we would expect. Critical thinking measures relate similarly to openness to experience as does general cognitive ability measures. They wind up being kind of weaker predictors of grade point average in college compared to, say, the SAT or the ACT. And they wind up being correlated with job performance, but again, less than cognitive ability measures. So are they basically watered down G measures, cognitive ability measures? We collected more evidence. Chris Huber and I have a paper coming out in Review of Educational Research where we revisited this question of, does college teach critical thinking? And the models we estimated based on a pretty large meta-analysis suggest that you do get gains on these ability measures over the years, and fairly big, depending on the model and the assumptions you make, somewhere between 0.4 to 0.6 D. But you get fairly similar gains on other ability measures. So again, are we just dealing with something that's nothing more than a cognitive ability measure? Well, I would say not necessarily. I think there's probably some specificity to some of these measures that's important. I'll give you an example. A student of mine and I published a little paper a while ago. She went into nursing. And we showed that the SAT and ACT was really extremely strongly related to the NCLEX, the nursing licensing exam, the NCLEX RN, which measures very specific knowledge about nursing. So very high correlation between the ACT and the NCLEX RN. So are they the same thing, right? Can we say that they're the same thing because there's a high correlation? Are the two functionally interchangeable? Well, of course not, right? Imagine you're getting wheeled into surgery at the University of Minnesota hospitals, and I come out in scrubs. And you say, well, you're starting to fade out, and you say, well, wait, you're an IO psychologist. And I'm like, it's cool. I've got high ACT scores. Hopefully we'll use the pokey thing. So instead, it seems likely that some of these measures are very specifically and locally useful. In other words, they're an acquired ability. So we decided to put this to the test using the concept of rationality, which is often discussed in the context of critical thinking. And rationality is an interesting idea if you're not familiar with it. It's taking the heuristics and biases that were identified, say, by Kahneman and Tversky, and instead of treating them as a human reasoning tendency, kind of a general tendency that people have, they're being treated as an individual difference. So although some people don't do things like consider base rates, some people do. And so maybe we can get at this kind of broad construct of rationality by giving people these assessments and on average seeing how well they do. So it's been proposed as essentially a very important ability domain. And we developed a lengthy measure and collected life outcome data to kind of start trying to test the question of, does it matter for anything? What does it relate to, and does it matter for anything? There's nothing more awful than going through factor analysis results at a conference. I think it's probably the worst statistical analysis to discuss. But I'll make the brief point that these things, availability, conjunction, problem, regression to the mean, sunk cost, do intercorrelate a little bit, not particularly strongly, and we do get a general factor out of it, but not a particularly strong general factor out of it, and not much beyond that, based on the data we have. We do see that the rationality measure correlates pretty strongly with cognitive ability, much like we saw with other critical thinking assessments. It correlates with the cognitive reflection task, and then it has some interesting relationships with other individual differences and background variables like education. It also is related to some decision-making styles as well. But when we look at things like life outcomes, generally speaking, we don't see much of anything for rationality. It seems to really function as a set of knowledge domains that people have been exposed to and they might have learned, but it isn't really strongly related to things like job performance, organizational citizenship behaviors, health, deviancy, and a mild negative relationship with satisfaction with life. If anything, the rationality kind of looks like a grumpy know-it-all characteristic. You get a little bit of negative agreeableness, cognitive ability, education, and less life satisfaction out of it. But I don't want to say, though, that efforts to try to measure specific abilities don't matter. We do see tilt in things like verbal and math scores. So this is based on some of our longitudinal data. We see that, the verbal measures from the SAT are slightly better related to English grades. Math, they're slightly more strongly related to math grades. And exposure in the population matters quite a bit when we're considering these things. So one of the findings from this paper that's coming out in Human Performance that I think is particularly interesting is the AP Spanish test on the whole isn't really strongly related with much of anything, a mild relationship with Spanish grades. But that group is a mix of native speakers who take the AP test and destroy it, and students who are studying Spanish and acquiring it as a new skill. So if you remove out people who self-identify as Hispanic, you start getting positive relationships between this measure and grades. We also see the value of specificity in graduate school admissions tests. Here I broke apart the GRE verbal, quant, and subject tests. And we see consistently that the GRE subject test is the best predictor of a range of different student outcomes in graduate school. And I think I suspect that part of that is just simply it's an indirect measure of motivation. Take the GRE psych subject test. It really isn't much more than introductory psychology. But who is it that does really well on it? Probably those students who just find everything about psychology fascinating and have taken as many courses as possible. And if they have a diversity requirement at school, they kind of get around it by taking psychology of women so they can get even more psychology into their curricula. So I suspect that we wind up getting relationships here that are in part due to motivational characteristics being reflected in people's investment in acquiring knowledge and skill.
Okay, back to mainstream admissions tests. Questions of bias surface a lot. Critic assertion the tests are biased against women and racial and ethnic minority students. Now, there's lots of different things that get put on the table when questions of bias surface. Mean differences in scores, we'll talk about that. Item content perceived to be culturally biased. Now, I'm going to argue that today that's off the table for the most part. For all major tests go through very elaborate item review and bias panels. So that, I think, is addressed successfully in tests like the SAT. Now, researchers, as opposed to critics, will also focus on couple things. Item bias, diff, and do individuals from different groups with the same total test score get the item right, W-R-I-T, look at that. Wow, with the same frequency. Way to go, Paul. Thank you for proofreading, Nathan. It's all on me, no question. With the same frequency, and again, that's a part of any major testing program. All items are pre-tested and reviewed, and items that are flagged for diff are removed. So you take that off the table. What remains as a big issue is the predictive bias question. Does a given test score forecast the same performance level for members of different groups? Okay, and we want to address that. First, mean differences. We do find differences in admissions testing. Black-white difference, about 100 points, about a standard deviation per SAT subtest. Hispanic, about 75 points, 3/4 of a standard deviation. Gender differences, smaller. Males higher on math. Just trivially different on critical reading, and women a little higher on writing. So that's back and forth, which group has the advantage. Now, clearly, we need to dig deeper than a description of mean differences to ask, are these real differences in the level of acquired knowledge, or does it reflect bias? I should also say, just as a side note, because looking at the clock, we are at least doing well, and we're not way behind time. One of the marvels of our ginormous data set. Whenever you see discussions of race and ethnicity, you always see the same discussion. Here's our results for Black, Hispanic, Asian. We don't have enough sample to report findings for American Indian students. Well, even though American Indian students constitute 1/4% of our sample, when you start with 1.2 million, so we've got 4,000 American Indian students, and so for us that's tiny, but for any other setting that's large. So I think we've got a paper out now that's sort of the first serious look at how things function for American Indian students, which is cool. Now, the predictive bias by race and ethnicity. So the key issue, we're running a regression line. We're looking at how actual performance differs from predicted performance, and we worry about underprediction, right? If minority group members perform better than the test would predict, then we say we underpredict, and that suggests a problem. Now, there's a long history. John Young looked at 50 studies of predictive bias in admissions testing, and no evidence of underprediction. In the organizational literature, there's much larger scale studies than that, similar finding. Colleagues of ours at the College Board, using the data that we are using, have looked at this large data set. And so in the data we're talking about here, again, no underprediction. So I think if you look at the data, there just isn't, on the issue of race and ethnicity, there isn't any evidence of the pattern that would cause a lot of problems, of a systematic underprediction of minority student performance. And we switch to gender, and you get a different finding. Tests for undergraduate admissions do underpredict women's performance. Women do better in college than their SAT scores say they should, and that's been known for decades. Women get higher grades than men with the same test score. Now, lots of intriguing things about it. First, that's only found with undergrad admissions. You don't find the same thing for graduate and professional admissions. You don't get that underprediction. You go, well, what's going on there? And the story becomes clear in a minute here. So 2 factors, I think, explain this. One, differences by gender in conscientiousness. Okay? Women are more likely to attend class, more likely to complete assignments, all these behavioral manifestations of conscientiousness. The way I like to explain it is, if I say in class, there's going to be 10 quizzes throughout the semester, and I'm going to drop the 2 with the lowest score, and so your sum across the remaining 8 will be your quiz grade. There's 2 reactions. Oh, good, I'll take all 10 and drop the 2 on which I did worst, or, oh, good, I don't have to take the first 2. And that is far more common among men than women. I mean, this is the behavioral manifestation of the difference in conscientiousness, and you see how that pays off. Okay, so differences in conscientiousness and differences in course-taking patterns. Nathan has touched on this. Well, no, this is a little different. No, men are more likely to take courses with tougher grading and tougher competition. In other words, more high-caliber students in the courses. So the differences in course difficulty and the differences in conscientiousness contribute to this. And those two features also help us in understanding why we don't see this for graduate and professional admissions. We don't see the same differences in course difficulty because the curriculum is more common. You don't see it not all over the book. Should I take English or should I take physics? If you're doing graduate work in industrial organizational psychology, it's a pretty common curriculum. And the people at the low end of the conscientiousness continuum tend not to be the folks who are continuing and pursuing graduate and professional education. Okay. Concrete example at Minnesota. Shifting here from Minnesota is a, quote, ACT school, so this is ACT, not SAT data. So we administered a conscientiousness measure to about 2,000 students in intro psych. Now, if you look at the data, if you just look at ACT scores and their grades in intro psych, women get higher grades than their ACT scores would predict, the standard finding. The test underpredicts. But put this little conscientiousness measure into your predictive model, and the underprediction goes away. Okay, so the coefficient for gender, it's an omitted variable problem in regression. We are, gender and conscientiousness are correlated, and without gender in the model, its weight goes to, without conscientiousness in the model, the weight goes to gender, and you have the appearance of quote, a problem that suggests something's wrong with the test. You look at it this way and you say, oh, I see what's going on. It's simply the difference in conscientiousness. We unpack this further. This intro psych course of ours has 4 components that go into the grade. Exam scores, weekly quiz scores. No, you don't get to throw some away, you just take them all. Points for optional participation in discussion sections, and extra credit for participating in psychology experiments. Now, it's pretty easy to say, if I take the 4 of those, the quiz will all get right. 2 are highly cognitively loaded and 2 are not, right? You know, exam scores and quiz are our cognitive components. Optional participation in discussion and extra credit for experiments are not. And what do we see? ACT predicts exam and quiz scores comparably for men and women. There is no underprediction. So the whole phenomenon of underprediction goes away if you are trying to predict, frankly, what the ACT should predict, your ability to acquire knowledge. Women earn more discussion points and more experiment points than men with comparable ACT scores. That's where the underprediction comes from. Again, this manifestation, behavioral manifestations of conscientiousness. So, the underprediction of grades is not due to bias in the ACT, but gender differences in these non-cognitive factors. With me? Okay. So we wanted to get through this in about 45, so there'd be some time for questions. So really, this is where we are. What have we tried to tell you today? Tests predict academic performance quite well, and they do so regardless of race and ethnicity, gender, or SES. They predict a broad array of academic outcomes other than grades, choosing a difficult curriculum, taking advanced courses, etc. And they predict subsequent non-academic outcomes as well, things that happen when you move out into, quote, the real world. One can find small sample exceptions to these findings, but we argue large-scale individual studies and meta-analytic findings demand attention. So that's our story, and I hope we've got some time for questions. Great.
Since I have the live mic, I'll ask one. What % of the variance in academic achievement is due to teachers? Individual differences in teacher performance?
A very good question, and one that we don't have data to address. I would love a chance to answer that, to address that, but we can't. Rich.
Just thank you for another breathtaking presentation. One of the greatest myths, of course, is that standardized tests are useless and measure nothing. We see this all the time with intelligence testing. We also have the myth that Bob Plomin talked about yesterday, that genetics really don't matter on anything important like intelligence. And Bob described a long-term strategy for dealing with persistent critics who are always wrong and ignore the data, which is the problem with the critics here. The problem is they just ignore massive data. I'm just curious if you have a similar long-term or short-term strategy to deal with this myth that just will not go away.
I have a I have a slightly amusing story about that. I got sent a paper the other day where someone was interested in thinking about intelligence, how reactions to intelligence and what contributes to success in life, either hard work versus innate abilities, are related to people evaluating different kind of hiring or admissions tools. And the paper was sent to me because I was the treatment effect in the experiment. They used a TEDx talk I did as the treatment effect to adjust people's reactions to it. And apparently I have a D of about 1 in terms of adjusting people's beliefs about intelligence. So I would apply me liberally across people.
Yeah, so I get an email from Nathan, just one-liner. I have a D of 1. Okay.
I think bringing forth powerful data, and I think also my personal experience, I mean, we're just kind of getting into the area of anecdote now. My personal experience is acknowledging some of the discomfort that people have with this, and I think it's real. And also being very clear that you do not believe the often attributed straw man argument that intelligence is the only thing that matters. Clearly, it's one facet of what's going on. And being very clear about that, my experience has been helps. Of course, there are going to be people who will never believe it. There's also a flat earth society you can find on the internet. So, you can't convince everyone. But I think recognizing and acknowledging that performance and success is complicated, that this is one thing. I like the analogy of going to the doctor. Your blood pressure certainly isn't the only thing that she should measure. But you'd be a little disappointed if they didn't, right? Because it's one useful and important piece of information.
Right. So you recognize, there's some people we're not going to make any progress with, and all you can do is roll your eyes and say, so it goes. But we spend a lot of time trying to get to audiences that we think are open to influence. I speak a lot to university admissions officers, folks of that sort, travel around doing that, and just try to tell our story. And you just try to patiently, calmly tell the story. I mean, there's so many other little things we didn't get to. I mean, the comment is, well, since high school grades are the single best predictor, which is descriptively true, they do modestly better than admissions tests, then that should be used alone. That makes no sense. There's no reason you have to pick one. It's not a contest. And just working through that logic and going through all these points and do what you do. But I say it certainly is frustrating working in a field where, in many cases, you're just hitting your head against a wall.
I also don't think we do ourselves any favor with how we present our results. A correlation of 0.3 can have an enormous impact on individuals, organizations, you name it. But then that gets turned into the coefficient of determination, and 9% of the variance isn't a great pickup line, right? So I think presenting data in other ways, that like some of the bar graphs, even simple approaches like that, are a much better way to convey that, yeah, it's, again, not fate. We're not saying it's fate, but it's important and we need to pay attention to it.
And I trust you all notice what we all notice. Anytime somebody squares a correlation, it is required, I think it's in the APA publication manual, that you need to insert the word only.
Right.
only 9% of the variance. So yeah, I mean, clearly that's an exercise designed to make something look awful. But if we work through utility theory,
right.
There is a direct linear relationship between the correlation itself and the value to the organization.
I mean,
that's linear.
If I could account for 9% of the variance in the stock market, we could hold this at my own island, right? So 9% can be quite huge.
Oh, Buzz, there we go.
Yeah, I don't want to take too much of time on this. You presented the statistical argument for testing and for cognitive testing, which I agree with. But although I'm pessimistic about your political possibilities, that Dick Atkinson made a different type of argument, and it's an argument which against the use of testing, and it's an argument that I have heard very interestingly in high schools, statewide testing, where, for example, they show that you get as much variance, or virtually as much, with multiple choice questions as you do with written answers. The written answers do not appreciably add to predictability, and they make the test much more expensive to score. But, as the people who did the test said, the test is also a policy instrument. This is behind some of Dick's objections to the SAT. He said that there are things on the SAT, for instance, well, they've dropped analogies, which I don't think you had a good statistical argument for it. But you had a good argument that having people practice analogies wasn't a useful expenditure of their time. In the high school example, the testing people said, the minute that we drop the writing from the test, the teachers will stop teaching writing. They will teach the test.
Right. I mean,
and the point I'm getting at is you make a great case so long as you stay with statistics. But could you comment on some of these policy issues?
no, I mean, policy is critically important, and I certainly understand how test affects behavior. A concrete example that's related, but not what we talked about today, I've spent the last several years as the lead technical advisor on the revision of the medical college admissions test. The new test just went into effect about a year ago. And there is a big change to the MCAT. It has historically been science. You get admitted into medical school on the basis of how much chemistry and biology you know. The new version, understanding what we as psychologists know about, that there's behavioral components to health. So we now have a social and behavioral science component to the MCAT. We're tentative, and we're not all the way there on data, but it doesn't look like this is going to increase the predictive power of the test. It won't decrease the predictive power of the test, but by changing the composition of the test, we are changing the way people prepare. We're changing their undergraduate curriculum. We're having students at intermed school with much more awareness of the importance of social and behavioral psychological factors for health. So yeah, when one thinks about test use, it is not merely a statistical issue. It's the policy issues and what you're trying to accomplish, take those into account, and I'm all for that.
I guess I would add that I think that face validity and content impacts are important. And I think that with computerized testing, we have more opportunity to do more interesting stuff and potentially influence policy through that. I do wind up being a little bit concerned about making tests too heavily specific, too heavily complex and content laden, because what schools are going to crush that? The ones who have money, right? The ones that are affluent are going to be able to do that. Vocabulary, analogies often get dumped on, but man, words are important. Take a high-frequency SAT word like convened a group or convened a meeting. That's really different than got some people together. I mean, there's nuance to that word and that language that I think is important and valuable. And the best way to get that nuance, to build that vocabulary, is through doing things like reading, which is invaluable and enriching. So while agreeing with your point in principle, I wouldn't even say so much that the current tests really fall terribly short of that. The SAT has large passages where you have to read and understand what they're talking about. You know, we do that every day. Pretty much regardless of what job you're in, you do that every day. So I don't think the results are quite so mysterious or so discrepant from what we want people to be able to do. And my hope is we can make them more so. So I agree with your point in principle.
So given the sex difference in conscientiousness, which is not well captured by the SAT, does high school GPA capture conscientiousness? If you just added that in, would the underprediction effect go away? And secondly, are there any other big five personality traits like openness that might also be predictive in college?
Sure, those are great questions, and thankfully we have answers. First, if high school GPA certainly has the big motivation component to it, and so a model that uses SAT and high school grade together, just doing that will reduce your underprediction. So from a operational point of view, we don't see the degree of female underprediction that you see if you're simply examining the test on its own. So that captures a good chunk of conscientiousness. And yes, in the study I mentioned, our Minnesota study, I was focusing on conscientiousness just to make it simple for today, but you're absolutely right. Openness and frankly, neuroticism both have a nice predictive role. So yeah, the catch is, so we know from this and a variety of other studies that if you could come up with a way to administer a personality measure that was not open to, being faked or coaching schools attacking it, we could do something with it. But that's the problem, is finding something that will hold up in an operational rather than a research setting. Yeah.
Hi, so as you'll know, Keith Stanovich has a book on what IQ tests miss, and his whole idea is that these rationality tests, like the critical thinking tests that you mentioned, don't correlate with intelligence. And I've never been able to believe that, because, and results like yours make a lot more sense. So what is he doing that you're not?
I'm not certain. There may be some measurement error things. All of our specific rationality subcomponents were measured by more than one item. So we're not using single item measures, we're using at least a pair for those, so that may be part of it. Some of it may have to do with the selection of specific heuristics and biases you're getting at. We wound up using ones that we felt we could measure fairly accurately. There are others. There's a laundry list of them at this point, so it may be which ones you pick. And I want to make certain everyone understands that I do think that some of those are probably locally important. Understanding the survivorship bias arguably partially led to the shuttle disaster, and a failure to recognize the survivorship bias arguably led to the shuttle disaster. Sunk cost decision-making biases people make all the time, whether it's with a relationship, oh, I keep putting so much time into our relationship, but he just won't commit, to cars, oh, I just replace the alternator, I'll fix the transmission even though the car's not worth it. So I do think that they're specifically locally probably important and maybe quite relevant in some occupational contexts, but what we see is that they correlate pretty strongly with cognitive ability. We have information that shows that exposure, having been exposed and taught to these before, is associated with knowing them, not surprisingly. So I would soundly put them in a knowledge and specific skill domain rather than being this kind of meta construct. Oh, we need to teach children critical thinking. No, you need to identify which specific skills are most relevant in life and work and happiness even, and teach those. So I've spoken about this in other contexts. I've always argued for let's make a list and talk about which ones we want rather than just saying, oh, we're going to teach them critical thinking. I think that's frankly absurd. Not that I have a strong opinion about it, but I think it's absurd.
Nathan, I'd like to respond to something Buzz said because it was very important, and it also touches on your example of the nursing exam being correlated with general ability measures. And there's this theme that cuts across a lot of the things we're talking about, and it's even related to fluid and crystallized abilities, as they're talked about in the theoretical literature. Just because something is correlated highly with something else doesn't mean it measures the same thing for all populations. My leg is probably correlated with all my other bones in my body to the same extent that the length of my arm is, but that doesn't mean they're the same thing. And within a culture, crystallized and fluid reasoning abilities measure essentially the same thing. It's when you go across cultures. And we have to be clear on what it is we're measuring. A lot of these aptitude tests, like the SAT, are designed to capture capacity to learn across multiple populations. A lot of the individuals who are in these populations haven't had equal opportunity to learn, and that's the design of that. And we have to be vigilant of what's being taught in the schools because people will teach to the test. But it's very different talking about assessing for individual differences in abstract learning capabilities versus the content people have acquired. And I think once we distinguish between those things, we can make a lot of progress.
We're out of time. Please join me in thanking the speakers.